graphs of quadratic function. Before that, you should know what is meant by the quadratic function. We are familiar with quadratic function already in factorization, those kind of lessons. So for an example, quadratic means if x of x, all the graphs should have only two graphs in 2D graph, two axes, x-axis and y-axis. Relation to x-axis, the y coordinates will change. So this is, for an example, I am drawing and explaining what is happening over there. Thereafter, let's show the proper graph. Initially, uh, when x is a particular value, this is the way you will have your graph equation. Y equals to x square plus x plus 1. This is your graph equation. Okay, this is your graph equation because quadratic means x should be in its, the highest power of x should be in its square form. Quadratic means binomial means no problem. If there are only terms in a function, that's called as binomial. There are three terms, that is called as trinomial. We are not going to bother about that one. Here only consideration is quadratic function. That means in a graph equation, okay, we are familiar with this one. Y equals to 2x. Y equals to 2x minus 3. We know how to draw the graphs for this one. Likewise, here highest index of x should be in its square form. These kind of graphs are called as quadratic function. Quadratic function. Now we will properly align some kind of data to plot our graph. That's what we are going to draw. Before starting to draw the graph, we need to gather some information and plan our graph. That is really important. I'll give you an example. This is your page. Okay, this is your page. So if you start your graph somewhere here, okay, graph here, sometimes you will end up something like this. We cannot finish the graph because lack of space. Outside of the page we cannot draw. Somewhere, sometimes when you start to draw your graph, you cannot finish this. That should be something like this only you will have. And here, so that's why planning of the graph, that is really important. Always start your graph in new page. In final O level exam also, you have enough pages. They will give you enough pages to draw your graphs, graph papers. So while starting, just start in the middle. Start in the middle. Thereafter, I will explain how to plan your axes properly. Let's look at them later. Then, um, the scale is also really important. Sometimes students will have more space in vertical orientation. In vertical orientation, you have enough spaces. So that's why they will keep two boxes. For one count, they are using two boxes. So one, here two, three. So try to understand, two boxes means 20 small boxes. 20 small boxes. In the uh, horizontal orientation, you didn't have that much space. So within 10 boxes, that means within one whole box, they will plan their graphs. This is incorrect. While you are planning your graph, the scale should be same. If you are taking 10 boxes, 10 small boxes in between x-axis, definitely in your y-axis also, in between values 0 to -1, you have to keep only 10 boxes. Even though you are having enough space, don't plan your graph a little bit like that. So then your graph should be like this. Okay, it is not the proper way to draw the graph. No, graph should be in a particular symmetrical way. This is the way we have to draw the graph. Before starting to draw the graph, the planning and where you are going to locate your graph in the page. Sometimes you have written something in the front. In backside of the page, don't start to draw the graph. Sometimes these letters which you have written on the back page, that will show some impression. Okay, impression to opposite side, to the back side. So you cannot plot the marks properly. Okay, so that's why while you are starting to draw the graph, just draw that in a new page. That is really important. Sometimes students will do something. This is their graph paper. While they are writing answers for other questions, they will keep the paper over this. Okay, over this they will keep and write. So the impression of your letter, some students will write hardly. Okay, their impressions are very thick. So in those cases, that impression will be appeared in your graph paper as well. So that is not a proper way to draw the graph. Okay, this is not a good one, no graph. So while you are writing, below your table you have a space. Okay, you have a space to keep your stuff. So in that you can keep your graph paper until you reach the graph question. You can keep that paper below. Then when you need that, you can start to draw that one. These are some really foolish mistakes students are doing. As I mentioned earlier, corresponding to x. Okay, x is a not changing parameter. In your exam, they will give you what are the x values you need to consider. That will be offered. But according to the change of x, the y is a changing parameter. You have to find the corresponding y value. Here x is starting from -3, -2, -1, 0, 1, 2, 3. These are the x values. Corresponding to that, the y values. We need to find the y values by ourselves. For that, you should have the graph equation. Here I'll give you the graph equation as y equals to x square minus 5. X square minus 5. This is the name of our graph. For each graph, there is a specific signature or identification. So, for this particular graph which we are going to draw, their identity, its identity is y equals to x square minus 5. So, we know the x values corresponded to that. We need to find the y values to complete the table before starting to draw the graph. So, I will find the y value for here first. X square minus 5. So x square, what is our x square? Negative 3. In this case, x is negative 3. Negative 3 square minus 5. Negative 3 square means negative 3 into negative 3 minus 5. Okay. Negative into negative positive. 3 3s are 9. So 9 minus 5, it is positive 4. At this point, when x is negative 3, at that place, y should be positive 4. Likewise, let's find for when x is equals to negative 2, negative 2 square minus 5. Negative 2 square means negative 2 into negative 2 minus 5. Negative into negative positive, 2 2s are 4 minus 5. 4 minus 5, it would be negative 1. Then let's find for negative 1, negative 1 square minus 5. Negative 1 square. Negative 1 into negative 1, it is positive 1 minus 5. It is negative 4. Then 0 square minus 5. 0 square is 0. Okay, just consider 0 square as 0. Minus 5 means this is not creating any impact on this negative 5. Nothing will happen. So this negative point remains same. Thereafter, let's substitute 1 instead of x. So 1 square minus 5. 1 square is 1 minus 5. It would be negative 4. Thereafter 2 square. 2 square minus 5. Here I had negative values. That's why I used the bracket. Okay. While you are finding the negative values indices, must use the bracket. Sometimes you will write negative 3 into 3 as negative 9. That is incorrect. No? Negative 3 square means negative 3 into negative 3. So that's why I used a pair of brackets. Since here I am using only positive values here, I am not using brackets. 2 here it's 4 minus 5 is negative 1. Likewise for 3 square minus 5, 3 square is 9 minus 5, it would be 4, positive 4. First of all, before starting the graph, you have to find their corresponding y value. This is really important. Here you can see a symmetrical relationship. Okay, since it is a quadratic function, there is a symmetrical relationship. The last both values are same. Look at this. Here 4, 4. Negative 1, negative 1. Negative 4, negative 4. Likewise, there is a symmetrical relationship with their y coordinates as well. This is also an identification feature in the quadratic function. Now let's plan our graph. So in x-axis, okay, in x-axis, I need the minimum value as -3. Minimum value -3. Maximum I need +3. So that's enough, totally enough to plan our graph in between in x -3 to +3. Likewise, in our y-axis, minimum value is -5. Maximum value is 4. This is totally enough to plan our graph. Don't exceed this limit. Just limit your graph within this limit. That is totally enough. Now let's draw. First, I will mark the coordinate. Starting from 4, 3, 2, 1, 0, -1, -2, -3, -4 until -5. Now let's draw over. This is y-axis. The name of the axis is y. Now next one is x-axis. 1. Keep the same space which you have taken in this axis. 1, 2, 3. -1, -2, and -3. And some students will plan, they have sufficient amount of space, so they will plan their graph like this, but their graph is like this. Okay, look at this. This is it looks funny, no? So according to your requirement only plan your graph. So these enough. Okay, these regions are not needed to construct this graph. Okay, this is waste of the space. So likewise, it is enough to plan your graph within this space. That's how you have to plan your graph. What is the maximum x and y, minimum x and maximum and minimum of both x and y, accordingly plan your graph. Now let's mark our coordinates. First coordinate, when x is -3, y would be 4. So this would be the first location, 3, 4. And next one, when x is -2, y would be -1. So this is the coordinate. And x is -1, y should be 4, -4. This is the location. When x is 0, y should be -5. Then x is 1, y is -4. X is 2, y is -1. X is 3, y is 4. This would be the location. Then by using your pencil, don't use rulers. Don't use rulers anymore. So just draw your graph carefully. Okay, just connect them by your hand. Connect them, and just take the curvature over here. This is the way you have to plot your coordinates to draw the proper graph. Okay, my one is also not exactly proper. While you are drawing in your page, you can properly just draw the curvature and plan your graph. After drawing, you can name this graph. Name of this graph as y equals to x minus 5. This is the name of the graph. The first question, the minimum value of this function. The function means after plotting this graph, this graph is considered as the function. Okay, this graph is considered as the function. The minimum value of this function means, just look at this, the minimum value at this point. Okay, at this point, at the lowest point, or sometimes they will ask as least point. Okay, least point or turning point. this graph is going downwards. Exactly. Suddenly at this point, okay, instantly that is changing its direction to its opposite and moving upwards. So that is the exact turning point or least point or minimum value of this graph. Minimum value, the coordinate does not ask, only the value is only asked. So minimum value of this graph, it would be y equals to 5. Y equals to 5. When y is equals to 5, in y axis, sorry, not 5, it should be negative 5. When y is negative 5, only the graph is in its minimum value. And the next one also same question. Coordinate of the minimum point. Coordinates of the minimum point. So we identify this one as our minimum point. Its corresponding coordinate. While you are writing coordinate, first you have to write the x value, thereafter y value. So its x value is 0, y value is negative 1. Sorry, negative 5. 0, negative 5. That is the minimum point. Coordinates of the minimum point. There are two questions, same but different. Minimum value of the function means only you have to write the y value. Coordinates of the minimum point means you have to write their respective coordinates. Now let's come to the important one. Okay, this is really important than other two questions. The interval of values which x for which function is negative. Function is negative. The interval of values of x which the function is negative. There are two key terms here. Values of x, function is negative. Let's analyze the graph first of all. Okay, this function. Function is positive and negative. Function is positive and negative. So that means this is our x-axis. Above this, the y values are positive. Above this, the y values are positive. Below this x-axis, below the x-axis, the y values are negative. Try to understand this clearly. This is our margin. Above this, the y values are positive. Below this, y values are negative. Function means I told you they've asked about the graph. That means they are corresponding y values. The interval of values of x for which function is negative. At where function is negative? The function is this one. Above this, the function is positive. So we don't want these two portions. We can totally split this graph into four portions. 1, 2, 3, 4. In 4 quarters, there are 4 pieces, 4 portions. So we can split this into 4. So we don't want these two portions as the function is negative because these two portions belong to function is positive. Okay, function is positive. But we need this one. Here look at this. In this one, in this quarter and this quarter only, function is negative. We have to find its corresponding interval of x, interval of x value. So below the x-axis only we will have the function as negative. So we identified these two regions are satisfying the condition of function is negative. So in this region, what is the x interval? So in your graph, just try to identify what is the exact decimal point of this region. Okay, what is the exact decimal point? Somewhere around negative 2.2. I'm not sure because I have to it in my screen, on screen. So in your graph paper, you can identify the exact value. So I will take it as negative. That is located in between negative 3 and negative 2. So somewhere here, I will take it as negative 2.2, here as positive 2.2. So when x is in this interval, okay, in this interval, when x is in between this interval, negative 2.2 to positive 2.2, in this interval only, the function is negative. That is our question. There are two key words in our question. The interval of values of x for which function is negative. We identify which region is going to give us function is negative below the x-axis. So in this region, we have to write their corresponding x interval. When x is located in between -2 to +2.2, -2.2 to +2.2, in this interval only, the function is negative. Function is negative. You cannot write only these values, because look at here, it is -1.8 somewhere, -1, 0, 1, 2. So within this region, when you select any coordinates of x, that will give you the function as negative. In between this region, all the x values will give you the function as negative. Function as negative. That's what you have to understand from here. Next question, the interval of values of x, here also interval, which the function is increasing positively. I told you that this totally the graph is splitted in between 4 quarters. Okay, this is I'm not going to name the quarters, just I'll use different colors. Look at this. This is a quarter. Okay, this one would be a quarter. Another one I will take, yeah, this is another quarter. And third one, this is another quarter. And this one also another quarter. So I splitted our total function into 4 quarters. Now correspondingly, let's analyze the graph to answer to the question. Interval of x for which function is increasing positively. First of all, you have to identify that is increasing or decreasing, positively or negatively. There are 4 possibilities: positively increasing, positively decreasing, negatively increasing, negatively decreasing. That's what we are going to analyze here. It is really simple. Look at this. Here, what is happening to their function? That means their y value 4, 3, 2, 1. This is decreasing. Okay, I will use an arrow to show this is decreasing. First, I analyze this is decreasing. 4, 3, 2, 1. This is obvious, no? Decreasing. Now look at this region. Here, let's find their corresponding y values for this function. -1, -2, -3, -4. In negative, numbers increasing mean that is decreasing. -1 is greater than -2. -2 is greater than -3. So in this region also the function is decreasing. Then let's come to our green color portion. Here -4, -3, -2, -1. So in this region, in this quarter, the function is increasing. Function is increasing. Then let's come to our fourth quarter here. 1, 2, 3, 4. Here also obviously the function is increasing. Increasing. Decreasing means just look at their values. Okay, corresponding y values, that is increasing means increasing, decreasing means decreasing. That's all. Now we need to find one more parameter, that is positively increasing or negatively increasing. That is also a key one. Let's analyze that one as well. So in the first quarter, this belongs to positive. Okay, in this region y is positive, no? In this region y is positive. So this is positively decreasing region. Positively decreasing region. Next one, here the y values, all the y values are negative. So in this region it is negatively decreasing. Negatively decreasing. In here y values are negative either and increasing. So this region negatively increasing. This region all the y values are positive. So that means this is positively increasing. Positively increasing region. I'll repeat it from the beginning again. First, I analyzed their corresponding values to find that whether that is increasing or decreasing. You can identify that easily. Then that is located in positive region or negative region with respect to what. Likewise, I analyzed all the regions. All the regions. Now let's come to our question. Back. So interval of values of x when the function is increasing positively. So increasing positively here, positively decreasing, negatively increasing, positively increasing, positively increasing. That means this is the quarter we need to concern. That is the one and only quarter we need to concern. So in this region, how can we write the interval of x? When x values, okay, this is the x value. When x values are exceeding this 2.2 limit, the function is positively increasing. Look at this phenomenon. When the x values are exceeding this 2.2, when x is greater than 2.2, not equals to, greater than 2.2, this function is positively increasing. So we identified this light blue color region is positively increasing. So its corresponding um, interval of values of x, it could be x is greater than 2.2. When x is greater than 2.2, you can obviously see the function is positively increasing. There is no any limit. When you draw the graph until infinity, it is going. Okay, that's why we are using this symbol to show the answer. When x is greater than 2.2, the function is positively increasing. That's all for the question series. So here I explain everything what do you want to answer. Okay, everything. These are the maximum kind of questions you will encounter in your exam paper. Minimum point or turning point, minimum that's coordinate. The function is negatively increasing, negatively decreasing likewise. Then function is negative or positive likewise. This is the maximum. If you could understand everything clearly, you can score maximum mark in your exam paper.